Hello everybody, hopefully you're all doing okay today, and today we shall be doing a video on differentiation from first principles. Now, when f of x is a function, we have determined that f dash of x, which is the differential equation, is equal to f of x plus h minus f of x all over h. And this is, of course, with limits as h tends towards 0. This all comes from the idea that if you had point P on a graph of, let's say, y equals x squared, for argument's sake, where x is equal to 3, and then you imagine and you want to find the tangent at this point, then you have a nice line going across here. But of course, if you imagine a different point, Q, which is only h larger than in x value, then you could just imagine a nice little triangle, which would give us a nice little gradient here from P to Q. And if you were to try and find the gradient between these 2 points, well, we'd have m, which is standard notation for gradient, y2 minus y1 over x2 minus x1, which is just change in y over change in x, which in this case will be equal to 3 plus h squared minus 9 over 3 plus h minus 3, which if we expand out will give us h squared plus 6h plus 9 minus 9, as we have there, all over h. 9 will cancel off, and this will give us a nice succinct h plus 6, which as h tends towards 0, as we're making this gap smaller and smaller to make these points closer and closer together, which will get closer to our tangent at this point, then we will find that it is equal to 6, which is where this idea comes from. So we can use differentiation from first principles in such a similar manner. Now, our first question will be to differentiate f of x equals minus 4x from first principles. Now, first, we shall write down f of x is equal to minus 4x. So if we remember our standard notation, f dash of x will equal limits as h tends towards 0. Don't forget that is important. F of x plus h, so in this case that will just be minus 4 times x plus h minus our f of x equation, which is minus 4x, so brackets minus 4x all over h. And then you would expand. So let's do so. So that will equal limits as h tends towards 0. We'll have minus 4x minus 4h plus minus is of course a plus 4x all over h. Those will cancel off, giving us minus 4h over h, which of course equals minus 4. So we needn't worry about the limits this time. But in future examples, and I feel like this may come in the next one, you may need to think about it. So, next question. Using differentiation from first principles, find f dash of x when f of x is equal to 3x squared. So if you'd like to have a go yourself, feel free, pause the video, have a crack at it, and we shall go through it presently. Right, hopefully you've all had a go, hopefully you've gotten the correct answer. If not, you needn't worry, because we're going to go through the question now and see where you went wrong. So, f of x is equal to 3x squared. So, if we're finding f dash of x, then we're going to have limits as h tends towards 0. Lest we forget, very important. You'll see why later. So we're going to have 3, substituting x plus h into our current equation. So that's wherever you see an x. So x plus h all squared there. Make sure you don't mix anything up with that. Minus 3x squared over h. Right, so it's some lovely expanding. Quite capable of that. Right, so we're going to have 3x squared plus 2hx plus h squared, close brackets, minus 3x all over h, which will equal a nice 3x squared, looks familiar, plus 6hx plus 3h squared minus 3x, forgot the squared there, squared. So those will cancel off. This is all over h, of course. So this will equal 6hx plus 3h squared all over h. So divide out the h's. We'll get 6x plus 3h. And as h tends towards 0, this will just become 3 times 0, which is, of course, 0. So that will give us a lovely 6x. And that is what you should get. So it doesn't seem too hard. You've seen what happens with the limits. Hopefully you can have a go at the next one. Hopefully you get it correct. If not, needn't worry. We shall go through it shortly. So, find y primed when y is equal to x squared plus 7. That's just another form of notation for f dash of x, the differential equation of y, or f of x, using differentiation from first principles. Sounds familiar. So, if you'd like to pause the video, have a go, feel free to do so. This is a prime opportunity for you, and hopefully you get it correct. Right, time to have a crack at it. So, what's our f of x value? Here you ask. Or our equation even. Our function is nice, x squared plus 7. Given in the question, of course. You don't have to write this out, by the way. I'm just choosing to just to show you the thought process. It's not necessary because the question tells you what your function is. So, f dash of x is going to equal, so remember you have to substitute x plus h into wherever there's an x in your equation. So in this example, it'd be x plus h all squared plus 7. Don't forget, just because that doesn't have any x values in does not mean we can just forget about it. And then we're going to have the minus our function as it is. So it's going to be minus x squared plus 7, all bracketed. You needn't show that if you just want to expand it ahead of time. Feel free, as long as you do it correctly, it matters not. This is, of course, all over h. I forgot the limits. If you happen to do that in a test or in a question and you notice, do just write your limits above or below, just as long as it's clear that it's with what you're working with, because it is vitally important to remember. So the limit is h tends towards 0. Remember this time, that's handy dandy. X squared plus 2 hx plus h squared, close brackets, plus 7 minus x squared minus 7. 7 will cancel off, all over h, do not forget. Otherwise you'd have a tough time finishing this because you'd be dividing by 0, which isn't quite plausible. Well, it's undefined anyway. So limits h tends towards 0. We're going to have x squared plus 2hx plus h squared minus x squared all over h. X squared cancel off to give us a lovely 2hx plus h squared all over h, which of course equals 2x plus h. And we still have a value of h here, but we needn't worry, as h tends towards 0, this will just become 2x. Hopefully you've followed all of that. And now, time for the final example. Hardest of them all, supposedly. So we'll have a go and hopefully get it correct. Follow suit. Right. So we want to find the gradient of the tangent of f of x, which equals 2x cubed plus x plus 7, at the point at which x equals 7 using differentiation from first principles. Right. Seems like a jolly good question to me. So, have a crack at it. Hopefully you'll get it correct. If not, you needn't worry. We shall go through and show you how to do it correctly. Right. So, hopefully you've had a go and gotten it all handy-dandy and correctamundo, and now I shall go through and hopefully follow as such. So, f of x is equal to x cubed plus x plus 7. Right. So, f dash of x will equal to, I forgot the limits, but don't worry, that's do try not to forget it, being a poor example here. So, x plus h, all cubed, plus, brackets, x plus h, no difference to that, plus 7, minus our current function, so minus brackets 2x cubed, plus x plus 7, all over h. Right, well, that looks rather nasty, doesn't it? Let's begin. So this will equal limit h tends towards 0. Right. To get started on expanding this, so we'll know that the first expansion will be that squared, so we're going to x squared plus 2hx plus h squared times x plus h. So that's x plus h squared times x plus h, which of course is x plus h cubed. Not x plus h cubed, but all of it cubed. Plus x plus h minus 7, plus 7 even, minus 7 will come sooner rather than later. Minus 2x cubed, nothing we can do with that yet. Minus x, minus 7. 7 cancel off, all over h, of course. Right, so we're going to take this down here. So what we have left is going to be 2 times x cubed, we're just expanding these brackets now, plus 3hx squared plus 3h squared x plus h cubed plus h minus 2x cubed. I forgot to mention the x's here. Cancel off, just noticed in transition. And that is, of course, all over h with limits as h tends towards 0. That's not at times, by the way, despite looking like a star, which hopefully you'll be stars at this after the video. Right, so that's going to equal, got to expand the brackets furthermore. I'm sure we're quite capable of that by this point. So it's going to be 2x cubed plus 6hx squared plus 6h squared x plus 3h cubed plus h minus 2x cubed. Those will cancel off all over h. Right, so that's going to leave us with 6hx squared plus 6h squared x plus 3h cubed plus h all over h, which will equal a lovely, a little bit tight here, 6x squared plus 6hx plus 3h squared plus 1. Right. Crikey. So, I'm going to rewrite that here, just for ease. Right, and as h tends towards 0, this will equal 6x squared, which is not affected because there's no h's. That will become 0, this is a h there, so will that, so we're going to be left with 6x squared plus 1. Job's a good one. Now, if you're thinking we're finished, then you're wrong, because we still, if you remember the question, need to find the gradient of the tangent of f of x, being this, at x equals 7. What a rather lovely number, 7. So what we're going to do is simply substitute x equals 7 into our equation. So at x equals 7, we're going to have 6 times 7 squared plus 1, so that's going to equal 6 times 49 plus 1, so that will equal 294 plus 1, equaling overall 295. And there we go. So hopefully you've followed all the steps required to do this. If not, feel free to replay parts of the video if you need a hand. If I got anything wrong, or if there's anything you're not quite sure about, then please ask in the comments with some help if you need it, and I shall endeavour to soothe your quest for knowledge on this. So, hopefully you've all had a good time, understood everything, and until next time, cheerio!